Hello friends, welcome to Quick Learn website, and I am very excited to inform you that in Quick Learn I have recently launched my website, that is www.quick-learn.in. This website is especially for all the engineering and diploma students and those students who will preparing for competitive exams. So in the blog section of the website, you can find the notes of all the electrical and electronic subjects, just like basic electronics, microcontroller, microprocessor, power electronics, and slowly I will add more notes in the website. And if you are preparing for any government competitive exams, then check also my MCQ series, that is multiple choice question series, and previous year question papers. That will help you in your competitive exams. Here I also upload the quiz test or mock test for ONGC, UPPCL, or for different type of competitive exam previous year question papers. Or for latest update, please join my Telegram channel. The link of my Telegram channel I will give in my description box. So stay continue and keep watching and keep visiting my website. Hello friends, welcome to Quick Learn tutorial series. In this video, I will explain you single phase Pullbridge inverter with RL load. This is lecture number 37 of Power Electronics series. So let's start with the topic. Here we study about single phase full bridge voltage source inverter with RL load. So this is the circuit diagram of single phase full bridge inverter. This circuit diagram basically consists of 4 thyristors T1, T2, T3 and T4 and 4 feedback diode D1, D2, D3 and D4. Every diode is connected in anti-parallel with thyristor, just like D1 diode is connected in anti-parallel with T1 thyristor, D2 diode is connected in anti-parallel with T2 thyristor, D3 diode is connected in anti-parallel with T3 thyristor, and D4 diode is connected in anti-parallel with T4 thyristor. Here Vs is the supply voltage. We know that in case of inverter, the input voltage is DC voltage. So here with the help of this battery, we provide Vs DC supply voltage. Now come at the load side. As I have already told, here we discuss single phase full bridge voltage source inverter with RL load. So here load is RL. So this is the complete description of single phase full bridge inverter circuit. Now here we study the behavior of the single phase full bridge inverter circuit when we connect RL load. So here RL load is connected between 2 points A and B. And here we consider that when current flow from A toward B, it means in this direction of current flow is considered to be positive, or this direction is considered as a reference direction of current flow and current is positive. And what about output voltage? Output voltage is also positive when A terminal positive with respect to B. Now the operation of the circuit is divided into 4 modes. So here we see, to understand the operation of the circuit, this is the total time period T. This total time period T is divided into 4 parts. First part is 0 to T1. This is the first time interval. Second time interval is T1 to T by 2. This is second time interval. Third time interval is T by 2 to T2. And fourth time interval is between T2 to T. So the whole operation of the circuit is also divided into 4 modes. So one by one I will discuss all the operating mode of inverter. Now consider mode 1. In case of mode 1, the time interval is T1 to T by 2. It means this time interval, T1 to T by 2. At this time interval, here we see we provide gate triggering pulse or firing pulse to thyristor T1 and T2. So this time T1 and T2 thyristor will be turned on. So when thyristor will turn on, they behave like a closed switch. So T1 thyristor is behave like a closed switch and T2 is also start conducting and behave like a closed switch. But what about T3 and T4 thyristor? this time T3 or T4 thyristor will be turned off. So they behave like a open switch. Therefore, the current flow from the supply voltage and follow the path supply voltage, T1 thyristor, load, T2 thyristor and back to the supply voltage. So here we see current flow from point A toward B in this direction across the load. So this direction is the reference direction of current flow and this current is considered to be positive. So current flow in positive direction, and due to the inductor in the load, because inductor is present in the load, current exponentially grow across the load, because the property of inductor is inductor cannot allow the sudden change in current. So first here we draw the output current waveform. At the time interval T1 to T by 2, a positive current flow across the load like this exponentially with respect to time. Because we know that inductor is present in the load, and due to inductor, the property of inductor is inductor cannot allow sudden change in current. So the zero current is not suddenly changed to maximum current. It will slowly increase and reach to its maximum value at T by 2. And we also know the second property of inductor. When current flow across the inductor, it stores energy in opposite direction of current flow. So in this case, current also stores some energy. So the voltage induced across the inductor is VL voltage. This is the self-induced voltage across the inductor, and the polarity of VL voltage is this terminal is negative and this is positive. Now what about output voltage? So current flow from A toward B terminal. So we know that current always flow from positive toward negative. So A is positive with respect to B this time. So voltage is also positive. And how much voltage will produce at output side? The total supply voltage Vs will be appear across the load side. So here we see at time interval T1 to T by 2, Vs supply voltage will appear across the load side. So this is the output voltage waveform. Now next mode is mode 2. The time interval of mode 2 is lie between T by 2 to T2. At this time interval, here we see D3 and D4 diode will be conducting. So this is the time interval T by 2 to T2. In this time interval, here we see we remove gate pulse from T1 or T2 thyristor. So T1 and T2 thyristor will be turned off and behave like a open switch. At this time, we know that due to the inductive load, the load current cannot reduces to zero instantaneously, because there is a self-induced voltage across the inductor that maintain the flow of current in same direction. Inductor having property, inductor cannot change current instantaneously. And here we see at the mode 1 time, inductor stored some energy. So this time inductor will release energy, and we know that when inductor release energy, it changes its polarity. So when in mode 1, inductor having polarity, this terminal is positive and this terminal is negative and current flow in this direction in mode 1. So this time inductor release energy and change its polarity. So this terminal is negative this time, this terminal is become positive and inductor release energy. So this time current flow due to inductor in this direction. Load D3 diode will conducting this time, D3 source and D4 diode and back toward the load. So current follow this loop this time. Therefore this time and inductor release energy is fed back the supply voltage Vs. So here we see in the waveform of output current, the output current decrease exponentially, and at time T2 it goes to 0. This is all due to the inductive nature of load. Again I will explain you. In case of mode 2, the time interval is T by 2 to T2. It means this is the time interval of mode 2. In this time interval, here we see we remove gate triggering pulse or firing pulse from thyristor T1 and T2. So thyristor T1 and T2 is turn off this time and behave like a open switch. But the load current cannot reduces to 0 instantaneously at this time interval, because we know that the property of inductor cannot change current instantaneously. So in mode 1, inductor stores some energy. So this time inductor release its energy, and we know that when inductor release its energy, it changes its polarity. So in mode 1, the polarity across inductor is this terminal is positive and this terminal is negative, and current flow in this direction. So this time inductor changes its polarity. This terminal is positive this time, this terminal is negative, and we know that current always flow from positive toward negative. So the direction of current is current flow from load D3 diode. D3 diode is conducting this time. Supply voltage Vs, D4 diode, and back to the load. Current flow from positive toward negative, and current follow this path. Therefore, this time energy stored by the inductor is fed back the supply voltage Vs. So the load current I0 is decreasing exponentially this time. So here we see at the waveform of output current, this time T by 2 to T2, the load current exponentially decrease, and at time interval T2, it will goes to 0. All this happened due to the inductive nature of load. And what about output voltage? Now what about output voltage between T by 2 to T2? In this time interval, here we see terminal A is negative with respect to B, because when inductor release its energy, it changes the polarity. So this terminal is negative. So current flow from B toward A this time. So this terminal is negative and this terminal B is positive this time, because current direction is B toward A. So output voltage is also negative minus Vs. So here we draw the output voltage waveform. In this time, when inductor release its energy, D3 or D4 diode conduct, and output voltage is minus Vs, because current flow from B toward A. Follow this path. So A is negative with respect to B. Next is mode 3. The time interval of mode 3 is T2 to T. It means this time interval. In this time interval, again we provide firing pulse to thyristor T3 and T4. When we provide triggering pulse to T3 or T4 thyristor, they will start conducting. So this time we provide firing pulse to T3 or T4 thyristor. T3 and T4 is turned on and behave like a closed switch, and T1 and T2 thyristor will be turned off and behave like a open switch. This time current flow from supply, we know that current always flow from positive toward negative. So the direction of current is supply voltage Vs through T3 thyristor, load T4 thyristor, and back to the supply voltage. So the current follow this path. This time current flow from B toward A. The direction of current flow is this. So this time current increase exponentially across the load in reverse direction. Here we see current increase exponentially across the load in reverse direction. So the current direction is negative this time. And we know that current always flow from positive toward negative. So this time B terminal is positive with respect to A. So output voltage is also negative. And how much output voltage? Minus Vs. The complete supply voltage will appear across the load. So here we draw the output voltage waveform. The output voltage is minus Vs at this time interval. And what about output current? As I have already told, due to the inductive load, current is reverse in direction. It means current is negative. But due to inductive load, inductor having property, it cannot change current instantaneously. So here current slowly increase exponentially with respect to time in reverse direction across the load. And we also know that either in reverse direction or forward direction, when current flow across the inductor stored some energy. So the self-induced voltage across the inductor is this time VL, and the polarity is this terminal is positive, opposite polarity, and this is negative this time, because inductor stored energy in reverse direction of current flow. So here we see at the output voltage and output current waveform, this time current is also increasing but in reverse direction, and due to nature of inductive load, current increase exponentially with respect to time in reverse direction, and output voltage is minus Vs. Now next mode number 4 is the time interval 0 to t1. It means this time interval. Now the question arises, we have to take this time interval. Why we take this 0 to t1 time interval? So here we see in this time interval after t, here we see D1 and D2 diode is conducting, and this time 0 to t1 also D1 and D2 diode is conducting. So both the time interval is same. So in this case, here we consider any one of the time interval after t or 0 to t1, because this is a continuous cycle, and when we continuously operate the inverter circuit, a points come where this time interval is come in this side. Okay, so both the 0 to t1 time interval and this time interval is same. So in this time interval, here we remove gate pulse from T3 or T4 thyristor. So this time T3 and T4 thyristor will be turned off and behave like a open switch, and due to turning off T3 or T4 thyristor, the load current cannot reduces to zero instantaneously, because due to the nature of inductor cannot change current instantaneously. So inductor slowly decrease current exponentially with respect to time, because in previous mode, it means in mode 3, inductor stored some energy in this direction. This terminal is positive and this terminal is negative, and we know that in this mode number 4, inductor release its energy. So when inductor release its energy, it changes polarity. So this time this terminal is negative and this is positive, and current always flow from positive toward negative. So current start following from load, D1 diode, supply voltage, D2 diode, and back to the load. So current follow this path. This time D1 and D2 diode will be conducting. Here we see this time D1 and D2 diode will be conducting, and current follow this path. So the direction of current is negative this time. Current flow in reverse direction. And here we see at the output current waveform, current slowly reaches to 0 at this time interval. Here we also see current slowly reaches to 0 at 0 to t1 time interval waveform. From this time interval waveform and 0 to t1 time interval waveform is same. And in both time interval, D1 and D2 diode will be conducting. And what about the output voltage? So this time A is positive with respect to B, because B is negative. When inductor release energy, it changes polarity. So this time B is negative and A is positive, and the direction of current flow is this. So A is positive with respect to B, voltage is positive. So here we see output voltage is positive, that is equals to Vs. So in this way we obtain the output voltage and output current waveform. So this is the complete operation of single phase full bridge inverter with RL load. So hope you like the video. For more interesting video, please like, subscribe and share my channel. For notes, please visit my website. The link of the website I will give in my description box, that is www.quick-learn.in. Here I also upload some MCQ question series and some mock test of previous year question paper just like ONGC, Metro Rail Corporation Limited, that will help you in your competitive exams. So stay continue, keep watching and keep visiting my website. Bye bye.